friends, today we're going to continue with our lessons on geometry. This is lesson 2, and we're learning about segments, line segments. Okay, and so what is a line segment? Let's jump right in. So a line segment is basically just a piece of a line. Uh, it is it's the piece of a line between two given points. And so here's an example of a line segment. This is line segment PQ. The way that we write line segment is similar to the way that we wrote line. We write the points, and then we put this line segment above it. Remember before with the line, we had the arrows on the ends. So now we just draw a straight line, no, no arrows on the ends. If we write something like this, if we write PQ by itself and we don't include the line above it, then we're not talking about the figure. We're not talking about the shape of the line segment. What we're talking about is the length of segment PQ. That's why it makes a difference. We write the line above it, we're talking about a shape, we're not talking about a number. If we have just PQ by itself, then it actually means the length of segment PQ. If two segments have the same length, then that means they are the same shape and the same size. When two objects are the same shape and the same size, we call them congruent, and this is the symbol for congruence. It's like an equal sign with a squiggle above it. And so here's an example of two segments that are congruent. RS and TU. If two segments have the same measurement, then what we do is we put these little tick marks on them like this. So these both have length 8. So I could write the length of segment RS equals 8. The length of segment TU equals 8. Since they have the same measurement, that means that they are congruent. And since they're congruent, we have these little tick marks indicating that. If you've got two different sets of lines that are congruent, then you can put two tick marks on two of them to indicate that they're congruent to each other, and then but different from the other ones that only have one tick mark on them. So we use multiple tick marks to indicate what's congruent and what's not. So if we're talking about shapes, shapes are congruent. So RS, we would say, is congruent to TU. Notice though now, without the line above, RS and TU here, then I'm saying the length of segment RS and the length of segment TU, those are numbers. And since they're numbers, I would say that they are equal to each other. So there's a difference. Pay attention to the notation. Really, the notation seems kind of annoying, but what would be much more annoying is writing everything out and using words to write out, all these words. The notation, it's just like a different language, and it's there to help make life shorter, easier. We don't have to write as much. It's just like another little language. That's why in your head, when you're reading problems and questions, you should translate it appropriately. When you're reading this, don't just say RS is congruent to TU. Think segment RS is congruent to segment TU. The length of segment RS equals the length of segment TU. The better you use the vocabulary in your head, the easier it's going to be for you to understand all this stuff. Okay, there are also some properties. You've seen properties of equality. Now we're looking at properties of congruence. If there is this type of thing where two figures can have the same shape and the same size, and so they're congruent, then let's see what we can come up with. First of all, the reflexive property. This is very simple. It's reflexive. Like if you look at your reflection in the mirror, you're looking at yourself. So it's the same thing, looking at itself in the congruence mirror. PQ, segment PQ is congruent to segment PQ. The symmetric property, that's you flip it back and forth. If segment RS is congruent to segment TU, symmetry, flip it, then segment TU is congruent to segment RS. The transitive property, just like the transitive property of equality, works for congruence as well. If segment PQ is congruent to segment RS, and segment RS is congruent to segment TU, then PQ is congruent to segment TU. So we're going to be using these properties when we get to trying to reason through solving problems, and it's what we call proofs, where we've got to show step by step our reasons for things. Next topic here is what we call a postulate. Okay. It's not an apostolate, like a ministry of the church or something like that. Postulate. Okay. A postulate is a statement that we think is true, but there's nothing before it that we can use to prove that it's true. It's something that we assume is true. The way the geometry works is we start with some basic terms, and then we have some things that we can define, and then we have some basic assumptions. And then from those assumptions and from those basic ideas, we can build up the rest of geometry. That's part of the beauty of geometry, is that you have these few basic ideas and you build up this entire system of coherent, purely logically connected thought. It's incredible. Just starting with a few basic ideas. Okay, so a postulate is an idea that we assume to be true and that we're then going to use later on in um, in other reasoning. So our first postulate is called the ruler postulate. Okay, this idea is that the values 0 and 1 can be assigned to any 2 points. So I can take any 2 points and assign the values of 0 and 1. What that does is it sets a measurement for me. That now has a measurement of unity of 1, right? Of this is 1, whatever, 1 unit, that then can set the pattern for other measurements and other units. And then the distance between any 2 points is the absolute value of the difference of their coordinates. That's really confusing. What are we saying? It, you're already familiar with this, right? You know this. This is stuff that you would be like common sense to you. But we just have to state it very clearly because we're going to start to build on these thoughts. So for example, like what is the length of segment YZ? Well, uh, Z has coordinate 4, Y has coordinate 1, and I want to find the difference. So we can take these coordinates and we can actually do them either way, 4 minus 1 or 1 minus 4. So let's see. YZ, so the length of segment YZ is the absolute value of 1 minus 4, or theoretically, this should give us the same answer. The length of segment YZ is the absolute value of 4 minus 1. Well, 1 minus 4 is negative 3. The absolute value of that is 3. 1 minus 4 is just 3. So we get 3. 3 units. We don't know what the units are here. It's not given to us, but that's okay. So that's what that's what the ruler postulate says. So it's just about having a unit of measurement and then being able to measure things. That's it. The next postulate is the segment addition postulate. And this tells us, again, this seems like it would just make perfect common sense, right? That if Q is between P and R, then the length of segment PQ plus the length of segment QR equals the length of segment PR. Makes perfect sense. And it follows from, we can't prove it from, but it does follow from the ruler postulate, just the way that we assign measurements to be taken. And so here's an example, right? If Y is on segment XZ and the length of segment XY is 5 and the length of segment XZ is 18, find YZ. Find the length of segment YZ. Draw a diagram. First thing, when you're coming up with any problem, when you're looking at something, you're reading it, draw a diagram. Geometry is like physics, like most math. You have to think with your pencil. Put your pencil on the paper. Don't try to picture it all in your head. Don't do that. Just draw it. It takes 2 seconds to come up with a drawing. So Y is on segment XZ. Okay. And it doesn't even have to be scale. Just make it messy. Just get something on the paper. Y. Okay. The length of segment XY is 5. I'm going to put that there. And the length of segment XV, so that's the whole thing, right, is 18. What is the length of segment YZ? So I'm going to call that X. Now, you could probably figure this out on your own. But the segment addition postulate tells us that the length of segment XY plus the length of segment YZ equals the length of segment XZ. Then I can substitute. I know that XY is 5. The length of segment YZ I don't know. The length of segment XZ is 18. And now I subtract 5 from both sides, and I get that the length of segment YZ equals 13. Right? And I give you a reason for each of those steps. Right? This is the segment addition postulate. And then I used substitution. And then I use the subtraction property of equality. Remember that? It's all there. I give a reason for each of these steps. And now we have a last thing is just the definition of a midpoint. So a midpoint is a point on a line that divides the line into two congruent segments. Okay, and so here, just the way that I have this marked out, M is the midpoint of segment JK. I have these tick marks to indicate that segment JM is congruent to segment MK. Okay, and so there you have lesson 2, all about segments, the segment, the ruler postulate, segment addition postulate, the midpoint, um, definition of what a midpoint is, and coming up with some of these, uh, looking at some of these properties of congruence. So good luck on the problem set. Thanks for watching. Don't forget to like and subscribe.